All right. So, what are the critical considerations and requirements for leveraging 5G to enable real-time monitoring, predictive maintenance, remote diagnostics, that sort of thing in industrial systems?
I think one element of it is taking a holistic view of what that's going to look like. A lot of the use cases, for example, that we just alluded to before, may have been focused on one aspect of machine health or in monitoring, and it may have been just about temperature, humidity, and such. It might have been about vibration. So understanding what are the characteristics that we're trying to capture. Do we need it on a real-time basis, or do we need it on a near real-time basis, or do we really just need it for archiving purposes? And once we have that information, what types of alerting and signaling do we have to do to react to that? So there's a lot of those considerations that it's great to throw some IoT sensors in and start testing something, but thinking about all of those those ripple effects that'll go into it. Now, we're in an interesting position in that space because the reality is nobody's going to look to Verizon and say, you know what, I want to have my $5 IoT sensor connected via cellular. So I'm going to suddenly put a $25 SIM card into a $5 sensor. That's not likely to happen. But with the scale of sensors and the possibility of having so many sensors in place in time, that density is either going to have to be accounted for with lots of wired connections or lots of low bandwidth applications or services that may not be able to support that type of connectivity. The other consideration is this sensor going to be located, is this machine health capability and monitoring going to be located under a roof, inside of a plant, or is it going to be outside of a plant? And we're seeing a lot of interest in how can I track what's going on outside, whether it's out in my yard, if it's at a factory, or whether it's in a mining operation or an agricultural operation, or if it's an oil field. All these large outdoor spaces, they have a whole different set of circumstances that have to be accounted for when it comes to machine health. So one of the things that we're talking to customers about as a critical consideration is it's important to map the bandwidth that is required for each use case, for each service, to what makes sense. If a sensor, for example, is spitting out 50 kilobits of information every 15 minutes, it's really hard to say that 5G is going to provide any meaningful value. It's complete overkill. On the other hand, if you've got large video files that are being captured and they're consumed at a 4K resolution, that's a 20 meg file that's being uploaded somewhere. And if you have lots of cameras doing that, the dynamics and the economics really change, and that absolutely plays well to 5G. And there's all sorts of things in between. We tell customers that it's going to be about network optionality. We're not likely to replace Wi-Fi in a lot of instances. It's going to be possible, but in many cases, Wi-Fi does a lot of things awfully well and will continue to do so. What we see is when an asset is in motion, whether it's an operator carrying a tablet, a smartphone, a scanner, or an assembly tool, whether it's an AGV or an AMR, anything that's in motion or anything that's carrying real high bandwidth and has low latency requirements is going to be well suited for a cellular-based approach. So we see it as complementary. What we really see 5G being able to do is replace a lot of wired connections, because in the past, the customer had no other choice. They had to go with a wired connection because of the reliability, performance, and security of a wired connection. They liked the agility and flexibility of a wireless connection, but it wasn't possible to combine and have the best of both worlds. 5G, for the first time, does offer that possibility, that you can have performance, reliability, security, agility, and flexibility all through one network. That becomes a game changer. So what we're talking to customers about is network optionality. 5G is going to be great here. 4G might be good here. LoRaWAN might be good here. Cat-M1 here. Wi-Fi here. It really will depend upon that mapping exercise to connect the right application to the right spectrum.
So can you provide any insight into the potential effects of 5G deployment on the design and implementation of energy efficient systems, intelligent power management, and adaptive motor control in the context of Industry 4.0?
Yeah, a lot of possibilities around that. One of the things that I think when it comes to things like energy efficiency and power management is that if you're going to just monitor, there's a lot of different ways to approach it. If you're going to be more proactive, and anything when it comes to power is going to have a real sensitivity to latency. So, and it's likely to demand something that's in the single digit milliseconds in order to facilitate that. So as we look forward to where connectivity meets power, if you will, that the low latency of 5G in those single digits, 2 to 3 milliseconds in some cases, that's going to be sufficient to enable an awful lot of those possibilities with respect to energy efficient and power management.